This is JEE Advanced 2020 Paper 1 held on 27 September. Now we are going to present the solutions from the platform of IIT Guru. As this is JEE 2020 Paper 1, Section 1. In this video we will go for Section 1. Although this Paper 1 consists 3 sections. Section 1 consists 6 questions. Section 2 consists again 6 questions. And Section 3 also consists 6 questions. In Section 1 there is negative marking, only one correct. And if you see, there are the 6 questions, here there are the 6 questions. And in Section 2, once again there are 6 questions, once again negative marking, but more than one correct. Partial marking is also allotted over there. And in Section 3, once again there is a numerical value type of question, and here there is no negative marking, which is advantage for the students, and full marks, that is 4 marks for each question, and again there are 6 questions. So you see the question pattern is this. This is at a glance on the paper. So we start our solution one by one. So in this video we will represent the solution of Section 1. So let's start our video right after this short break. And if you are first time on my channel, then please subscribe and hit the bell icon button to get the video first. Of the quadratic polynomials, C and D are the complex roots of this quadratic polynomial, and we have to evaluate this expression. So if you equate these two polynomials to 0 and then get the relation between AB and CD, and then put these values here in this expression, and in this way you can get the result. So let's start. So that's why what we say here, from this first equation, what we call A plus B equal to, that is minus 20. What do you say about A into B? That is the product of roots. So here that is minus 20. Similarly, C and D, which are the complex roots of this another equation. So C plus D, what we call here, that is again minus B by A you can use. So here you will get plus 20. And now C into D, that is what we say 20. Now open this expression, expand it. Let this expression, that is AC, first of all multiply with this in bracket. So what we call A square C, here we can write like this, A square, and if you take out common over here, C, that you will find A square plus B square under bracket, that is small c, and then after minus, similarly C square under bracket, that is A plus B, and now that is plus D times of, and what we call A square plus B square. Then after, what do you say here, minus, when you take out D square common here, from here BD square, D square common, that is A negative D square, no? So A plus B. Now from this first and third term, if you take out A square plus B square common over here, so that what we get here, A square plus B square under bracket into that what we say C plus D, and then after minus of A plus B, and here what you will get, C square plus D square. Okay, so this becomes C square plus D square. Fine. Now by using these all data here, as A square plus B square can be evaluated by using this square formula, that is A plus B whole square minus 2AB, that what we say here, we can say C plus D, and for this A square plus B square you can say A plus B whole square minus 2AB, this is into another bracket, And similarly here also, that what we call a plus b, here we can say for c squared plus d square also, in similar way, c plus d whole square minus 2cd. I'll put this in bracket. And now substitute these values. As you know, c plus d, that is 20. And here a plus b, that is minus 20 whole square. That is, that is 400. And then after plus, you say 2ab, because ab is negative. So negative, negative, positive. So 20, 20 double, that is called 40, 40. 40, 40 minus. Now, what about a plus b? Once again, that is 20. And that what we call c plus d, that is 20. So 20 whole square, once again, that is 400. And then after minus 2 times of cd, that is positive. So negative the sign retain here. So 2 times double 20, 20, that is 40, 40. And here what we call, if you see over here, then that is 40, 40 positive, and here negative. So negative of negative, that it will be positive. Means this is a plus b, that is minus 20. No? So that we have to make plus. So now you see here minus 40, 40 and plus. This term related after multiplying with 20. So finally what we call 20 into 400 and 20 into 400. That is 8,000 plus 8,000. That is what we call 16,000. 16,000. And hence D option is correct. So in this way we can handle this question. This is the question number 2. A function f such as r to r is defined by fx equal to mod x under bracket x minus sin x. So first of all, redefine this function as fx equal to that what we call here minus x under bracket x minus sin x, and here that is x under bracket x minus sin x. In both the cases, here x is means less or equal to 0, and that is here x is greater than 0. You can put here also greater or equal to 0 and less than 0. It's dependent upon you. Anyhow, so that what we say here means f dash x. Here you can say fx, you can evaluate fx, you can say over here, that is negative of x square, negative of x square plus x sin x, okay, and then after x square and then minus x sin x. Here what we recall, that is x less than 0, and here you can say x is greater or equal to 0. You can put over equality anywhere, here, either or here. It's dependent upon you, you wish. So here what we say, if you find f dash x, then what do we call about this? We can say here that is minus 2x and plus that we say x differential of sin x, that is cos x, and then after plus sin x, then x is less than 0. And what do we call here 2x, and then after that is minus x cos x, and then what we say here minus sin x, and here that is x is greater or equal to 0. Now f dash x can be rewritten as f dash x, we can say here minus, you can use this 2x for this and this, so minus bracket what we say x minus sin x, one can recall, and here that is minus x bracket 1 minus cos x, this is for x is less than 0, and for x greater or equal to 0, you can write here x minus sin x, and then after plus x under bracket 1 minus cos x. Okay, so what we recall over here, for this is x greater or equal to 0. For x greater than 0, as we are going for differentiability, you can write greater than 0 here. You need to write equal to 0 over here for f dash x. So better just because differentiability you have to check for the existence. So differentiability not exist at x equal to 0, as this at mod x also function is not differentiable. So we are doing like this way. Now let's see. As you know, here x minus sin x. If you see the idea of x minus sin x, what about x minus sin x? In x positive, it is x is greater than this, and in negative, or x minus sin x is, it is x minus sin x. X minus sin x is say negative. Negative. You can check with the graph here. If or either or expansion, if x is negative, and here that we say, 1 minus cos x is always positive. 1 minus cos x. So here this is always positive. Due to this negative, this one become positive. So entire this positive and this is positive. So second term will be positive. And if you see here x negative, this is negative here. So this is positive finally. And here, of course, this is positive for x greater than 0. And this will become here greater than 0 for x greater than 0. Right. So what we recall over here, that is that in nutshell, the conclusion is there that this all implies here, that is f dash x is always positive. So f dash x is strictly positive. This shows that function is here increasing function for x belongs to all real number. So this shows that fx is increasing function. As fx is increasing, so we can say this is 1 1 function. So if it is 1 1, now check for 1 1, it's okay. Now check for onto function, and for onto you have to find the range here. So the range should be equal to r to be onto. So let's see about the range. So better just find limits value is at limit x tends to infinity and limit x tends to minus infinity for this function fx. So if you see here, limit x tends to infinity, limit x tends to, here I have in space, so I am writing over here, limit x tends to infinity fx. If you find the limiting value is attained and it is equal to infinity, and if you see limit x tends to minus infinity, then what we call here for this fx, then what we recall that it is minus infinity. This shows that the range of the function is all real number. So the range of the function is all real number. So and here codomain is also all real number. So this function is onto. So onto and 1 1, and hence we can say C option is correct. So yes, C option is correct for both 1 1 or onto, is also called inject. Question number 3. There are the two functions given over here, and you have to find the bounded area. Also, we have to consider this is in first quadrant. These values are given in the options. So analyze this fx and gx. You see here there is a mod. So fx can be redefined as, let redefine this fx. The critical point is 1. So for x greater or equal to 1 and for x less than 1. Let's think about it. So what we recall over here, that is x greater or equal to 1, we can say e power x minus 1 minus e to the power 1 minus x. What about here? That is 0, cancel, and gx will be same as it is. Now you have to see the point where f and g meets, but here for x greater than equal to 1. For x greater than 1, if you see where that meets, this implies f equal to g. If you equate it, then this implies, you just equate this result to this. So x will become, if you solve, half of ln 3 square. Ln, you say that is 3e square, right? Just solve this. So finally what we recall that x equal to, one can also say ln root 3 and e. So at this point the function will meet, and fx becomes 0 at x equal to 1. Okay, here you have to write greater than. Yeah, just you write here is the 1. Okay. So for that is at x equal to 1, what happens? Gx also vanishes. Clear? So what we recall here that Gx is positive. Better just draw the graph. So let's draw the graph over here. Let this be x-axis and this what we call y-axis. And now draw this graph of fx first. So that is the point here. Let's say this point is 1. At these points the graph is 0 coming over here. So here 0, and from here the graph uplifts like this way. And if you differentiate and double differentiate, you check function is increasing and concavity downwards here, and x equal to 1 if you see about gx. And here what we say, gx is of course positive, gx plus 1 is positive, and if you differentiate here, you will find gx, g dash x becomes 0, means here you see g dash x becomes 0 at x equal to 1. So you check here, and so means there is a minima point, a maxima you say, as g dash x is positive throughout. If you double differentiate, then it's positive concavity upwards, means the function pattern is like this way. Let's see. So gx can be written as gx. Let's hold the gx. So at x equal to 1, here there is a minima point somewhere. You can solve also what the point is there, and let at this point. So here it just cuts at y-axis somewhere. No need to test over here. This is y-axis. This is what we call x-axis. And now we have to find this bounded area. So the required area can be evaluated as, that is, we say this area we have to account over this one. Okay, so this is gx, and this part is x equal to 1. So from required area, let's say a can be evaluated as 0 to 1, and integral of half of this. You have to integrate this gx up to 1 only on the bounded, on the x-axis, bound of gx on x-axis. So half of simply e power x minus 1, and here that is plus e power 1 minus x, and then what we call dx plus. Now here you have to go ahead for this one, 1 to this one. So from here, that is 1 to integrate this one ln, you can say e root 3, e into root 3, that is, you can say also root 3e. So ln e root 3, that is half of e to the power x minus, means that is gx minus fx. So e to the power x minus 1, that is e to the power x minus 1, x minus 1 plus e to the power 1 minus x, that is gx, and from this result you have to subtract, that is e to the power x minus 1 minus e to the power, that is here 1 minus x, and this much you have to integrate this. So dx. Okay, fine. Here you have to consider this half. You can take out half else here. So finally, if you integrate this, the result of this one here, e power, that is same. Here what we saw, that the result will be 2 minus root 3 if you integrate this, and the result of this part is half of e minus 1 by e. So the final Answer is A option. Next we go another method for question number 3. As fx is this one and gx is this. So if you define this fx, let me define fx as previously in previous method also we have given this idea. So for fx, what we say, x is greater or equal to 1, that is as it is, e power x minus 1 you have to write, and minus, that is e power minus of x minus 1. So that is minus of x minus 1 you write over here. And for x is less than 1, that is 0. And gx is as it is, okay. So therefore here it's same as fx equal to g. For x greater than 1, somewhere these two functions meet over there. So this implies what we say, 2 e power, let me account over here, x minus 1, and that is minus 2 e power minus of x minus 1, and hence we say this is equal to, as this one is f, and after multiplying with 2, cross multiplication, that is e power x minus 1, and here that is plus e power 1 minus x, that was from g, this one gx. So equating this all, you can get the value of x over here. So solving, we get e power x minus 1 is equal to 3 times of e power 1 minus x, you can recall over here, and here you say e power, that is 2 times of x minus 1, and that is equal to 3, and hence we say x equal to, that is half of ln 3, okay, and plus 1. Now you have to draw the graph over here. So let's draw the graph of fx first. Let me draw the graph, this one. First of all, draw this as, let this be x-axis, and this what we call over here y-axis, and let's draw fx. What is fx there? For x less than 1 up to 1, that is, the result is 0 somehow. This result is 0, and beyond x equal to 1, this is the function, goes like this way somewhere, and then after for gx, you can recall this as gx here. So for gx you say at x equal to 1 it finds minima point. So here we get like this way, and at x equal to beyond 1 it just intersects somewhere, and this is the point where what we see over here, that is x equal to, let's say this is this what we call here, that is x equal to this one, half ln 3 plus 1. So x we say half of ln 3 plus 1. Okay, so on this point, so here in this method what we are doing over here, to required area, you integrate this blue segment, blue graph gx, from 0 to this point. So let's say this is the required area. Let me write over here. This is a required area here. You can say required area that we can recall 0 to, that is half ln 3 and plus 1, and here you have to integrate gx, there is a bound area, and minus, then after you have to go for this yellow segment, yellow graph means fx up on x-axis. So now we have to integrate 1 to half of this same limit, half of ln 3 and plus 1, and here that is fx dx. Now to solve this, what we say here, gx, this blue portion, if you find this blue area, that is the integral of 0 to half, that what we call ln 3 and plus 1, that is gx, we say e power x minus 1 plus e power 1 minus x dx. If you solve this and integrate, what do you call here, that is, after integrating, this will become e power x minus 1 as it is, and minus of e power x 1 minus x, you know. So minus x plus 1 we write over here, and from the limit 0 to half of ln 3 plus 1, this limit, and solving that what we say here, half of e power 1 by 2 ln 3 minus e power minus 1 by 2 ln 3, and solving this all what we say here, that is this part, this blue part only, and for this yellow part when you solve that, result will be here, that is integral, that what we call here, let me solve this one, 1 to this one, 1 to 1 by 2 ln 3 plus 1, and here we have to integrate this fx dx, that what we call over here, that is 1 by 2 e, here over 0 is left over there, so solve for 0 also, and that is minus half of, when you substitute 0, then you will get half of e power minus 1 minus e, that is under bracket, so half. This portion is the integral of blue part, and now for the yellow part, the result is, that is e power 1 by 2, you have to write. That was correct. Here what you have to do, no half. So here what you have to do, integration of this, that is e power simply 1 by 2 ln 3 and plus e power minus 1 by 2 ln 3, and here that is what we say, that is plus 2, minus 2, and minus 2 after substituting 1. So you have to subtract this portion, this yellow portion from this blue portion, and finally what do you get over here, that is here the result is 2 minus root 3, over here this is 2 or negative, that will become plus 2, and here that is root 3, and plus finally what we say, this negative portion will becomes here, that is half of that what we call e minus 1 by e, that is the final result. And in this way you get here 4, that is the ellipse, and one parabola is given, and here that is tangents to the parabola and the ellipse at the point P are perpendicular to each other, whereas this point P is the end points of latter sector, and you have to find the centricity of the ellipse. So okay, let this be x-axis, and this what we call y-axis, and here you draw ellipse 1, ellipse which is vertical over there, ellipse, and then you have to draw the parabola, and at the latter sector this one and this portion, this is, let this point be P, at which where the tangents are orthogonal. Here these two curves are, so this is orthogonal, and this be lambda, and this is 2 lambda, and this what we call y square is equal to 4 lambda x, and this is the ellipse given here, x square by a square plus y square by b square is equal to 1. So the equation of tangent here we get, once again we can go through two different methods over here, as this question is from coordinate geometry, so just we are coming through coordinate only. So equation of tangent, you write equation of tangent to the parabola, y square equal to 4 lambda x, that is y by 1 means y into 2 lambda, and that what we call 2 lambda under bracket x plus lambda, and hence the equation of tangent will become x minus y plus lambda equal to 0. Let us say equation number 1, and therefore slope of this tangent, that is tangent P to the ellipse, that is 1. And similarly for this ellipse, you can find the tangent of this ellipse also. So tangent on that ellipse is, that is at point lambda. So that is x into lambda upon a square plus y into, that is 2 lambda upon b square is equal to 1. And hence the slope of tangent is negative coefficient of x upon coefficient of y minus lambda radiated, and hence we say b square upon 2a square. And as this is the slope, let's say this is m2, and let's say this is slope m1. So as these two curves are orthogonal, so orthogonals are curves are said, two curves are said to be orthogonal if their tangents at intersecting points subtends right angle, and here that is perpendicular, it is given in the question. So 1 into, that is negative of b square upon 2a square, that is minus 1. And in this way you can get the value of b square by a square. So finally what we say, b square by a square, that is 2. And you know the eccentricity of the ellipse, as eccentricity is asking over here. So you know what is the eccentricity formula? Eccentricity of the ellipse is under root of 1 minus a square by b square. As we know, the b square by a square is equal to 2. So again reciprocal, is equal to under root 1 minus, that is 1 by 2. And hence we say that is under root 1 by 2. So e equal to 1 by root 2 is the correct option. So this is the fourth question. This question also can be considered by using the slope of the tangent of parabola by simple differentiation. If you differentiate this parabola and differentiate this ellipse, by using differentiation you can get the slopes, and simply the product of slope, that is minus 1 due to this orthogonality, and as we are said to perpendicular, tangents are perpendicular. So in this way also you can find the eccentricity of the ellipse, that is 1 by root 2. Okay, let's go another question. Let C1 and C2 be the two biased points such that the probabilities of getting head is in a single toss are 2 by 3 and 1 by 3 respectively. Suppose alpha is the number of head appears when C1 is tossed twice independently, and suppose beta is the number of head appears C2 tossed twice independently. Then the probability that the roots of the quadratic questions are real and equal. So for the real and equal roots, what the condition is? The condition is here, discriminant is equal to 0. As this implies, here what is b square, that is alpha square, and that is minus 4 beta equal to 0, so equal to what we call 4 beta. So what the possibility of alpha beta will be? Alpha beta possibilities are, you see here, maybe if you give alpha as 2, then beta be 1. So, or another possibility, that is maybe 0 and 0, correct? This is also no other possibility. So the required probability is given by, that is 2 by 3 for this one, and here let this be 2 by 3 whole square in this case, and then after 1 by 3, and then you say 2 by 3, and these all twice, so factorial 2. Okay, and another case, that is once again, that is 2 by 3, so what do you say, whole square, and that is 1 by 3 whole square in case of 0. That is you say that is solving what we call 20 by 81, and that's the answer. So let's go ahead for the question number 6. Consider all the rectangles lying in the region x, y, r to r. X lies between 0 to pi by 2 in first quadrant, and y, that is 0 to 2 sine 2x, means under this curve 2 sine 2x. So, and the area of the rectangle which has the maximum perimeter among all such rectangle, having one side on the x-axis. So better just draw the graph here. Let this be x-axis, and this what we call here, let's say y-axis. Let's say this is y-axis. Now draw, and let's say this is x, and this what we call y-axis here, and now draw the graph of y equal to this one 2 sine 2x. So the graph goes like this one. Okay, so that is 2 sine 2x, and here you just draw this one. That is rectangle. Rectangle is somewhere here. This rectangle, and this one, and this is, let's say this is the rectangle, and let's say this point is here what we call A, B, C, D. Name it A, B, C, and D. So this point will be as 2x, so this point will be pi by 2, and here so it will become pi by 4 as argument is double. Now perimeter, what do you say? Perimeter, let's say P, that is equal to twice of between this one. Just join this line here. Say this part, and then after we go ahead for 2 times of that we say 2 alpha. Let's say this is alpha. This will be alpha. So 2 alpha and plus 2 cos 2 alpha. Okay, this is the parameter. Okay, so you have to maximize this rectangle. Fine. So that is, this implies for maximum minimum dp by d alpha. You have to make it 0, and this implies differential of this one's cos, that is minus sine 2 alpha, that we say sine 2 alpha will become, that is 1 by 2, and this implies alpha will become pi by 12. Okay, so now differentiate double or check for maxima and minimum. So d square p double derivative alpha is square, let's say this one, that is minus 16 cos 2 alpha. This implies that d square p upon d alpha square at alpha equal to pi by 12. The result is negative. So the area of the rectangle, therefore area of the rectangle, let me write here, area of rectangle can be evaluated as 2 alpha into 2 times of cos 2 alpha. So what we recall here, that is 4 pi by 12, and finally what we say cos pi by 6. Hence we get pi upon 2 root. Okay, so that is pi upon 2 root 3. C options.